There is a kind of quiet architecture beneath your skin, an invisible scaffolding that silently determines how young you look, how strong you feel, how smoothly your joints move, and even how fast your cells repair themselves. Modern science has been uncovering something extraordinary, the very protein that shapes your face, strengthens your bones, supports your blood vessels, reinforces your gut lining, powers your muscles, and maintains your organs, is also one of the most influential molecules connected to healthy aging. Researchers have found that this structural protein isn't just about beauty or elasticity. It plays essential roles in metabolism, inflammation control, wound healing, cardiovascular resilience, and even the rate at which your cells experience wear and tear. Some scientists call it the molecular glue of longevity. Others describe it as the body's natural youth system. As we explore it together, you'll discover how profoundly this molecule affects almost every internal process, and why restoring it has become one of the most studied strategies for extending both health span and vitality. Collagen is one of the most abundant proteins in the human body. But what makes it remarkable is not only its quantity, it is its function. It forms the framework that gives tissues their shape and strength. When collagen levels decline with age, the body doesn't just show wrinkles. It experiences measurable structural changes that influence movement, stability, and cellular function. Scientists now understand that collagen affects everything from joint comfort to vascular flexibility, to how efficiently your cells respond to oxidative stress. This means that supporting collagen isn't a cosmetic idea. It is a biological strategy that reaches into the deepest parts of the aging process. The body naturally produces collagen, but the rate at which this happens decreases steadily after the mid-20s. What researchers find interesting is that this decline doesn't just change appearance. It alters the mechanical properties of connective tissues, bones, tendons, and muscles in ways that directly influence longevity. A drop in collagen affects the strength of your bones because collagen is what gives bones their flexibility before minerals give them hardness. It affects the cushion in your joints because collagen forms the matrix inside cartilage. It influences the stability of your muscles because collagen holds the fibers together, allowing them to contract efficiently. It also supports the tissue that protects your organs, including your heart and liver, meaning collagen has a far deeper role in long-term health than people historically assumed. Recent scientific investigations show that collagen contributes to metabolic balance by supporting healthy blood sugar responses and helping maintain lean muscle mass. Muscle is one of the strongest predictors of longevity, and collagen is a structural component that helps muscle fibers repair after daily stress. This means that collagen isn't simply part of your body. It's part of your body's strategy to remain strong and functional through the decades. As collagen declines, the risk of injury increases, the ability to recover slows down, and tissues become more vulnerable to everyday strain. Another fascinating discovery relates to inflammation and immune function. Collagen peptides appear to support the gut lining and help maintain barrier integrity, which influences whole body inflammation levels. A stable gut lining reduces the chances of unwanted molecules entering the bloodstream and triggering immune reactions. Researchers studying longevity often point out that inflammation control is one of the most important predictors of aging well, and collagen's influence in this area has become a major topic of interest. There is also growing evidence that collagen interacts with antioxidants in a unique way. Since collagen is rich in specific amino acids like glycine, proline, and hydroxyproline, it provides raw materials that help support cellular repair processes. Glycine in particular has been studied for its potential effects on sleep quality, nervous system calmness, and metabolic stability, all of which matter tremendously for long-term health. Some scientists have suggested that modern diets may not provide the same collagen-rich components that historical diets naturally included, which makes supplementation an area of intense research. As you consider how deeply collagen influences the body, it becomes clear that this protein operates far beyond the skin's surface. It shapes the skeleton, the muscles, the connective tissues, and even the microscopic structures that keep your organs supported and functional. The more we learn about collagen, the more it becomes evident that it is part of the body's internal strategy to resist physical decline. Understanding how collagen is formed, how it breaks down, and how it can be supported is essential for anyone who wants to extend not only their lifespan, but their quality of life as they age. If you look closely at how scientists study longevity, you'll notice something interesting. Many of the tissues that degrade fastest with age, joints, ligaments, cartilage, bone matrix, blood vessel walls, and skin elasticity, all depend heavily on collagen density and quality. When collagen weakens, tissues stiffen. When tissues stiffen, stress increases on surrounding cells. Over time, this accumulates into the kind of functional decline that people usually associate with aging. This is why maintaining collagen isn't just about external appearance. It is about preserving the internal mechanics of the body that make movement, comfort, and vitality possible. And perhaps one of the most fascinating insights is that the body responds dynamically when collagen peptides are consumed. Instead of using them only for skin or joints, the body sends signals to fibroblasts, the cells responsible for producing collagen, telling them to work harder. Studies show that collagen peptides act like tiny messages reminding the body to maintain its structural integrity. This signaling effect may be one reason why supplementation appears to support multiple systems at once. As we continue, you'll learn how collagen interacts with longevity on a molecular level, how it influences everyday energy, how it affects organs like the heart and liver, and how this ancient protein may be one of the most underestimated tools for staying strong, resilient, and youthful, far beyond midlife. Collagen's connection to longevity becomes even clearer when we explore how it interacts with cellular repair. One of the core principles of aging biology is that the body gradually loses its ability to repair itself as quickly as damage occurs. Collagen provides the raw materials and the structural environment needed for tissues to rebuild after daily stress. When collagen levels are adequate, microscopic injuries in tendons, ligaments, cartilage, and even skin can be restored with greater efficiency. When levels decline, that repair slows down, creating a cycle where damage accumulates faster than it can be corrected. Scientists refer to this as repair deficit, and it is one of the early signs of biological aging. Supporting collagen, therefore, indirectly supports the body's ability to maintain structural integrity over time. Another aspect of collagen that heavily influences healthy aging is its role in bone metabolism. Bones are not static structures. They are constantly being broken down and rebuilt through a process called remodeling. Collagen forms the inner framework of bone, giving it flexibility and resistance to fracturing. Minerals like calcium and phosphorus attach to this collagen scaffold to create strength. When collagen declines with age, the mineral structure loses stability, increasing the risk of microfractures and bone weakness. Research shows that collagen supplementation can enhance bone mineral density in some individuals, most likely by providing the amino acids required for rebuilding the bone matrix. Since fractures are one of the most serious age-related risks, anything that strengthens bone architecture contributes meaningfully to longevity. Collagen also supports the health of blood vessels. Arteries and veins rely on collagen for flexibility and structural support. When collagen breaks down, blood vessels can become stiffer, making it more difficult for the heart to push blood efficiently. Vascular stiffness is one of the hidden markers of aging and is associated with reduced cardiovascular resilience. By maintaining collagen in the vessel walls, the circulatory system can remain more elastic, allowing for healthier blood flow and less strain on the heart. This is one of the reasons collagen is increasingly studied in relation to cardiovascular aging. An equally important area where collagen affects longevity is joint health. Cartilage, the smooth tissue that allows bones to glide without friction, is largely made of collagen. As collagen declines, cartilage thins, making movement uncomfortable and reducing a person's ability to stay physically active. Movement is a major determinant of longevity. Individuals who remain active tend to have better metabolic health, stronger muscles, and more stable moods. When collagen supports joint comfort and mobility, it indirectly supports all the habits that contribute to a longer, healthier life. Muscles also rely on collagen in a crucial way. The connective tissues that wrap around muscle fibers, tendons, and ligaments are rich in collagen, giving muscles the ability to withstand tension and recover after exertion. Modern research shows that collagen peptides combined with resistance training can increase muscle mass and strength more effectively than training alone. This is likely because collagen supplies the amino acids that muscle repair mechanisms need, especially glycine and proline, since maintaining muscle mass is one of the strongest predictors of healthy aging. Anything that enhances muscle quality plays an important role in longevity. Collagen's influence extends into metabolic health as well. Some studies suggest that glycine, one of collagen's primary amino acids, helps support healthy blood sugar regulation and insulin sensitivity. Metabolic stability is a major factor in long-term health because fluctuations in blood sugar contribute to oxidative stress and inflammation. By supporting metabolic balance, collagen becomes part of a larger network of nutrients that help the body maintain energy, stable mood, and efficient cellular function. A particularly interesting area of research involves collagen and the gut. The digestive tract is lined with connective tissue that depends on collagen for strength and elasticity. Collagen peptides appear to help maintain the intestinal barrier, reducing the chances of unwanted particles passing into the bloodstream. When the gut lining becomes more resilient, the immune system experiences less unnecessary activation. Since chronic inflammation is a major driver of aging, strengthening the gut barrier indirectly contributes to overall longevity. The gut also plays a role in producing neurotransmitters, absorbing nutrients, and regulating hormones, meaning that collagen supports systems far beyond digestion. Skin, although often associated with beauty, is one of the largest organs of the body and one of the clearest indicators of internal aging. Skin cells respond directly to the presence of collagen peptides by increasing their own collagen production. As a result, elasticity improves, hydration increases, and the skin becomes better at withstanding environmental stress. These improvements are not only external. Healthier skin also functions as a more effective protective barrier against microbes and pollutants. The skin's resilience contributes to overall immune function, making its health another piece of the longevity puzzle. Another surprising role of collagen involves sleep. Glycine, a major component of collagen, has been studied for its calming effects on the nervous system. It may help regulate core body temperature at night and promote deeper rest. Quality sleep is essential for longevity because it is during sleep that the body performs many of its repair processes. When collagen-derived nutrients support better sleep, they indirectly support cellular regeneration and hormonal balance. Collagen's involvement in detoxification is another area of interest. The liver uses glycine for the process of conjugation, a key step in neutralizing harmful substances. A steady supply of glycine supports the liver's ability to process and eliminate unwanted compounds more efficiently. Since the liver is central to metabolic health, hormone regulation, and overall vitality, collagen's contribution to liver function may play a meaningful role in long-term health. The more deeply scientists explore collagen, the more interconnected it appears. It is not simply a structural protein. It is a biological resource that the body relies on for dozens of functions associated with healthy aging, from tissue repair to inflammation control, from bone strength to metabolic stability, from muscle performance to restorative sleep. The benefits extend across nearly every system of the body. As collagen levels fall over the decades, these systems gradually lose efficiency, but restoring the building blocks can help the body re-engage its natural repair pathways. As we look deeper into the science of aging, it becomes clear that longevity is not determined by a single organ or a single process. It is the result of thousands of interconnected systems working together smoothly. Collagen sits at the center of many of those systems, acting almost like a stabilizer that keeps tissues from breaking down faster than the body can rebuild them. One of the most overlooked areas where collagen contributes is the health of connective tissues that hold internal organs in place. These tissues ensure that organs such as the kidneys, liver, and intestines maintain their structure and function. When collagen weakens, organs may shift, lose some stability, or experience increased mechanical stress, all of which affect long-term vitality. Another remarkable role of collagen involves blood circulation at the micro level. Tiny capillaries rely on collagen to maintain their shape and prevent leakage. These small vessels deliver oxygen and nutrients to cells and carry away waste products. When collagen supports capillary integrity, tissues receive better nourishment and experience less oxidative stress. Good microcirculation is closely linked to healthy aging because cellular health is determined largely by the quality of the blood supply. As collagen strengthens the walls of these tiny vessels, the body becomes more capable of sustaining energy and resilience through the years. Collagen also interacts with hydration in a unique way. Inside the body, collagen-rich tissues function almost like sponges, holding moisture and releasing it as needed. This hydration isn't only about keeping the skin supple. It affects how smoothly joints move, how flexible tendons remain, and how effectively cartilage absorbs impact. When collagen levels drop, hydration decreases, and tissues lose their shock-absorbing ability. Over time, this dryness contributes to stiffness, discomfort, and reduced mobility. Maintaining collagen helps restore the water-binding properties of connective tissues, which supports ease of movement and long-term joint comfort. Another fascinating discovery relates to collagen's influence on mitochondrial function. Mitochondria are the tiny power generators inside cells, and they play a direct role in aging because they control energy production and are vulnerable to damage. The amino acid glycine appears to help protect mitochondria from oxidative stress, supporting more efficient energy metabolism. Healthy mitochondria are essential for maintaining muscle strength, brain function, and metabolic stability, all vital components of longevity. When collagen supplies glycine to the body, it provides one of the nutrients that mitochondrial protection depends on. The nervous system also benefits from collagen in important ways. Nerves are surrounded by protective sheaths made partly of collagen. These sheaths ensure smooth signal transmission and help protect nerves from damage. When collagen declines, nerve conduction may become less efficient, which can affect reflexes, coordination, and sensory perception. By supporting the tissues around nerves, collagen contributes indirectly to balance, stability, and overall neurological function, abilities that become increasingly important as we age. Collagen's connection to wound healing offers another insight into its importance. As people grow older, wounds tend to heal more slowly because collagen production decreases. Collagen is essential for closing wounds, regenerating tissue, and forming new blood vessels at the healing site. Supplementation has been shown to support faster recovery from minor injuries by providing the raw materials needed for these repair processes. Faster healing reduces the risk of complications and helps maintain independence, a key factor in longevity. Even the lungs rely on collagen, more than most people realize. The structure of lung tissue includes collagen fibers that allow the lungs to expand and contract efficiently. When collagen is strong, the lungs maintain elasticity, supporting healthy breathing. When collagen breaks down, lung tissue may stiffen, making breathing less efficient. Since oxygen delivery is fundamental to every system in the body, supporting lung structure indirectly supports long-term vitality. Hair and nails also rely on collagen-rich structures for growth and strength. While these may seem like small details, they reflect the body's internal protein status. Thin hair or brittle nails can be early signs of declining collagen availability. When collagen levels improve, many people notice stronger nails and more resilient hair, indicating that the body has regained some of its protein-building capacity. These outward signs often align with deeper improvements in connective tissues. Collagen also interacts with hormones in subtle but meaningful ways. For example, maintaining stable blood sugar and supporting muscle mass both influence hormonal balance. Glycine may help regulate cortisol levels, creating a more balanced stress response. Since chronic stress accelerates aging by increasing inflammation and oxidative stress, collagen's role in supporting calmness and metabolic stability indirectly contributes to longevity. Another area of interest is oral health. Gums, teeth-supporting ligaments, and the jawbone all depend on collagen. When collagen weakens, gums may recede and teeth may lose stability. Healthy collagen levels reinforce the tissues that support oral structure, reducing the risk of long-term issues that can affect overall health. Researchers note that oral health is strongly linked to systemic inflammation, making collagen's contribution to gum health another piece of the longevity equation. The immune system also relies on collagen-rich tissues. The barriers that separate internal systems from external threats, such as the gut lining, respiratory tissues, and skin, depend on collagen for strength. When these barriers are intact, pathogens have a harder time entering the body. A strong barrier system reduces immune overactivation, which preserves energy and protects tissues from chronic inflammation. As collagen supports these protective surfaces, it enhances the body's resilience against everyday stressors. What makes collagen especially valuable from a longevity perspective is how many systems rely on it simultaneously. It is not like a nutrient that influences one isolated pathway. It supports structural strength, metabolic function, gut integrity, nervous system health, sleep quality, muscle performance, and vascular resilience, all at once. Aging affects multiple systems at the same time, so nutrients that support multiple systems have an outsized impact on long-term well-being. Collagen's broad reach is one reason it has become central in discussions about maintaining strength, mobility, and vitality through the later decades of life. Its simplicity is part of what makes it powerful. Collagen breaks down into amino acids and peptides that the body easily recognizes and uses. Once absorbed, these peptides circulate and interact with cells in connective tissues, sending signals that stimulate natural collagen production. This signaling effect is a major reason why collagen supplementation shows benefits in different tissues, despite being taken orally. The body reacts to these peptides as if it is being reminded to reinforce itself from within. Collagen's influence on longevity becomes even clearer when we examine how it interacts with daily resilience, the ability of the body to endure physical, metabolic, and environmental stress without breaking down. One important area where collagen contributes is tendon elasticity. Tendons transfer force from muscles to bones, allowing every movement, from walking to lifting, to occur smoothly. When tendons lose collagen, they become less flexible and more prone to injury. Scientific studies show that collagen peptides can help improve tendon strength by increasing collagen fibril density, reducing the risk of microtears. Strong tendons make physical activity safer and more sustainable. And regular movement is one of the strongest predictors of long-term health. Ligaments also depend on collagen for stability. These tough bands of connective tissue support joints and prevent excessive movement that could result in injury. With age, ligaments may weaken, leading to instability and reduced confidence in daily activities. Supporting ligament integrity through adequate collagen intake contributes to overall balance and reduces fall risk. Falls are a major concern in aging populations, and anything that strengthens structural stability plays a role in extending independence and vitality. Even the heart benefits from collagen more than many people realize. The heart's valves and surrounding connective tissues rely on collagen for proper function and durability. When collagen maintains structural quality in these tissues, the heart can pump more efficiently, supporting long-term cardiovascular health. Researchers studying aging often emphasize the importance of maintaining flexible, strong connective tissues in and around the heart, because this contributes to smooth blood flow and reduces strain on the cardiovascular system over time. Another key area of interest is the role collagen may play in supporting metabolic flexibility. This refers to the body's ability to transition efficiently between using carbohydrates and fats as sources of energy. Glycine, abundant in collagen, is involved in several metabolic pathways that influence how efficiently the body adapts to these shifts. Metabolic flexibility is associated with better energy levels, improved weight stability, lower inflammation, and stronger longevity markers. By contributing to metabolic balance, collagen supports the internal environment that allows cells to function optimally. Collagen also plays a role in regulating body composition. Lean body mass, especially muscle tissue, is one of the strongest determinants of aging well. Collagen peptides have been shown to support the repair of muscle fibers after daily activity, especially in combination with resistance training. Improved muscle quality helps maintain strength, posture, and mobility, all of which support longevity by reducing the risk of injury and improving metabolic health. Maintaining muscle mass also supports glucose regulation, which further protects the body from metabolic decline. Another fascinating area of research focuses on collagen's interaction with the brain. The brain contains extracellular structures that help support neurons, and these structures require collagen-like molecules to maintain stability. Some of the amino acids found in collagen may help support neurotransmitter balance, including glycine's calming influence on the nervous system. This contributes to mental clarity, better sleep quality, and overall nervous system resilience, factors that affect how well the brain ages. Collagen's assistance in maintaining the structural integrity of the gut lining also provides indirect cognitive benefits. A stable gut barrier can reduce systemic inflammation, and long-term inflammation is known to influence brain aging. When the gut and brain communicate more effectively and inflammation levels are lower, cognitive aging may progress more slowly. This connection between gut health and brain function is one of the most active fields in longevity research, and collagen supports one of the main structures involved in this connection. Another crucial factor is oxidative stress, the accumulation of damage from free radicals. While collagen itself is not an antioxidant, some of the amino acids in collagen help support the body's antioxidant systems. Glycine contributes to the production of glutathione, a powerful internal antioxidant that helps neutralize oxidative stress. Higher glutathione levels are associated with better cellular repair, improved immune strength, and slower biological aging. This means collagen plays an indirect but meaningful role in the body's ability to protect tissues from everyday damage. Collagen also contributes to long-term mobility by supporting cartilage resilience. Cartilage is often one of the first tissues to show signs of aging because it receives less blood flow and regenerates slowly. collagen peptides have been shown to stimulate chondrocytes, the cells responsible for producing cartilage, encouraging them to maintain and rebuild the joint matrix. This contributes to smoother movement, reduced discomfort, and greater independence in daily activities. Maintaining cartilage health is one of the most effective strategies for preserving mobility, which is closely linked to longevity. Even the body's ability to perform under stress is influenced by collagen. When connective tissues are strong, the body can endure physical challenges without excessive strain. When these tissues weaken, everyday activities become harder and more taxing. Collagen supports the physical foundation that allows the body to stay active, balanced, stable, and capable. The more capacity the body has for movement and adaptation, the more likely it is to maintain healthy aging patterns. The role of collagen in hydration extends into internal organs as well. The kidneys, liver, and digestive tract all contain collagen-based networks that help distribute fluid properly. This internal hydration system supports nutrient absorption, detoxification, and tissue elasticity. When these systems remain hydrated and flexible, they function more efficiently, supporting long-term vitality. The cumulative effect of collagen is what makes it so relevant to longevity. It supports the structure of the body, the repair of tissues, the regulation of inflammation, the stability of metabolism, the resilience of the nervous system, and the efficiency of circulation. As collagen levels decline with age, all these systems lose some of their functional strength. By maintaining or restoring collagen availability, the body gains a better chance of staying strong, mobile, and resilient far later in life. This interconnected influence is why collagen has become such a central topic in modern longevity science. Its benefits are not limited to a single organ or a single cosmetic improvement. Instead, collagen supports dozens of systems at once, reinforcing the body's natural design and helping preserve its ability to repair, adapt, and thrive. As research continues, more insights will emerge about how collagen interacts with the aging process. But what we already know points to one clear conclusion: supporting collagen is a practical, science-backed way to help sustain the internal strength that longevity depends on.